Hey everybody, our work with line segments inside of triangles continues with this lesson about midsegments. We previously learned what a median was, what an altitude was, and now we're about to learn what a midsegment is. Some books call it a midline, but since it doesn't go on forever, it's a line segment. We decided that we think midsegment is a better name for the term. So here we have a triangle on a grid. This is what we're going to use to discover what a midsegment is. And the instructions for part A say find the midpoint of AB. So I'm going to use half the rise and half the run, and my midpoint ends up falling right there at 7, 10. And it says to call that M. Step 2 says find the midpoint of BC and label it N. So I'm going to do the same thing and use half the rise and half the run, and I end up here. The midpoint is called N. And then the final set of instructions says use a straight edge to connect M and N. And segment MN is our new segment in a triangle, the midsegment. Let me get back to where I was. Okay, let's try that again. Segment MN right here is called the midsegment. And it says compare the two segments, AC and MN. So MN is our new midsegment. Let's compare it to AC, the base of the triangle. So one thing that stands out to me right away is they are both horizontal line segments, which means that they are parallel to each other. So there's two things that's true about a midsegment. One is it's parallel to the base. And then let's check out the lengths and see what we notice. So MN, since it's horizontal, I can easily count and see how long it is. It's 5 units long. AC, let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 units long. So when you compare the length, you can see that not only is MN parallel to AC, but MN is half the length of AC. So these are two facts that we're going to use about midsegments moving forward. So as a quick check, do we know the difference between a midsegment, a median, and an altitude? So it says to draw the midsegment parallel to AC. So I'm going to leave AC alone. I'm going to find the midpoint of AB, put ticks on it. I'm going to find the midpoint of BC and put ticks on that one. That line segment MN is my midsegment. Mine doesn't exactly look parallel to AC, but that's because I didn't draw my lines very well. All right, part B is the median. Remember that median goes to the middle of AC. So I'm going to go tick, tick. I'll call it M. BM is my median. It goes from the vertex to the middle of the opposite side. And then my altitude to AC is going to go straight down from B and be a right angle. I'll call that N. BN is the name of my altitude. So you can see that median goes from the vertex of a triangle and altitude goes from the vertex of a triangle, but a midsegment actually doesn't. It connects two midpoints in a triangle. All right, let's solve two problems dealing with midsegments. So the first one is really quick. We learned two things about a midsegment. It's parallel to the base and it's half the length of the base. So first off, just because it looks like a midsegment, we don't want to assume that it is. So I see here with the tick marks that it truly is a midsegment because it is marked as B and C are the midpoints of the two sides. So all I need to do then is say, well, it's half the length of the base. So all I need to do is cut my 24 in half. And x equals 12, and I'm done with that problem. So we're going to do one more, slightly more complicated, but same idea. GI is a midsegment of triangle FHJ. We can label it with tick marks if we want. And then it says GI is 2z plus 8, and then FJ is 8z minus 5. So we want to make an equation. The biggest mistake that I always see is that people try to set these two expressions equal to each other, but are the lengths equal? No, the midsegment is half the length of the base. So you could take half of 8z minus 5, but I think what people like to do typically the most is to take the length of the midsegment and double it. So I'm going to write it like this, but you could jump right to just calling it 4z plus 16 and then set it equal to the base. So when you distribute, it's 4z plus 16 equals 8z minus 5. And then we can just solve that equation just like we've been doing all year. So I'm going to take the smaller z's, subtract those from both sides. Then I'm going to add 5. I can tell that this is going to work out to give me a decimal answer, and that is okay. So Z equals, let's check, 21 divided by 4, 5.25. And then it says find the length of FJ. So we just can substitute it back in here for FJ. 8 times 5.25 minus 5. 8 times 5.25, I'm doing this on a calculator, minus 5 is 37. So FJ equals 37. If you wanted to check and make sure that you did this correctly, you could also plug the 5.25 back in for GI. I'm doing that right now. And you get 18.5, which is in fact half of 37. So that does make sense. All right, the final thing that I want to show you is just people are always like, where am I ever going to see these line segments? And there's one place where I see all sorts of different things about parallel lines, perpendicular lines, triangles all the time, which is on a map or dealing with roads. So these might be streets that you're familiar with. This is a map of somewhere in Evanston. And I just happened to notice that right in this map of Evanston, I see a triangle and I see what appears to be a midsegment. So you never know when you might need to know if two streets are parallel to each other or how many blocks long something is. And so you just never know where something like this might come up. And I use it a lot when I'm dealing with maps and geography and stuff, especially because I live in Chicago and the streets are set up nicely for using a grid. So that's our lesson on midsegments, and let me know if you have any questions. Bye.